The normal distribution is probably the most important distribution in all of statistics. We're going to be using it throughout the rest of the course and in the next course as well. So over the next few minutes, I'd like to be able to show you how we're going to find probabilities of normal random variables. So first off, what is a normal random variable? Well, a normal random variable is one that has the familiar bell-shaped distribution that I'm sure you've seen before. So let's go over to the sketchbook here and draw a normal curve. So this is a normal distribution. So most of the mass is in the center, and then it has tails, symmetrical tails on either side that extend off forever. Well, let's now go back to the course packet, and I think at this point it's probably best to look at a problem. So let's flip ahead to the next page. Let's do the first problem. So in the first problem, we're told that the amount of ore measured in tons in a segment of a mine follows a normal distribution. So you can think about this as a random experiment. Remember, a random experiment is some well-defined procedure that has an uncertain outcome. Well, the well-defined procedure is we go remove all the ore from a mine, then we weigh it and find out how much it weighs. Now, not all segments weigh exactly the same amount. Some are going to weigh more, some are going to weigh less, but we know that the distribution of these weights will vary according to a normal bell-shaped curve. Now, we're also told that the mean of all such segments is about 185 tons, and the standard deviation is 40 tons. So I'm going to go put that into my little figure here. So the mean is 185, and I like to keep track of my standard deviation up here. So sometimes we have mines that have more, sometimes we have mines that have less than 185, but on the average we have 185. Now let's go see what they want us to do. So we're asked to find the probability that the amount of ore in some segment is less than 175 tons. So let's go back to sketchbook, and I'm going to first define a random variable. So let's say that x is the amount of ore, and we might want to put tons here. Now we could go label this as well. So the axis here, the horizontal axis, is showing x. So across all possible executions of this random variable, this describes the distribution. So sometimes we get a very big segment, sometimes we get a segment that isn't so big. Now we've been asked to find the probability that some segment is less than 140 tons. So, oopsie, scratch that, 175. So x is less than 175. Now, somewhere over here is the value 175. As always with probability histograms, if we have to find a probability, that corresponds to the area. So the chance of having a segment that weighs less than 175 tons is equal to this area here. All right, how do we do this? Well, if you recall with the age distribution, we had a table, and we went over to the cumulative column, and we could just look up the probability of that. Well, the same is going to be true with normal random variables. The table, however, is going to be given to us in Excel. So let's go over to Excel. And in Excel, there is a function called normdist. Now we get a little bit of help here. Normdist takes 4 arguments. The first one is the x. So the x in this case is 175. The mean of the distribution was 185. The standard deviation was 40. And the last argument is asking us whether we want a cumulative distribution. We do. So this is going to be telling us what is the chance of a normal random variable being less than 175 if its mean is 185 and its standard deviation is 40. So if I hit enter, we see that the answer is 0.4013. So let's just go write that in. So 0.4013, and that is our answer. So that's all there is to finding probabilities under a normal curve. Just use that norm dist function. Let's go back to the course packet for a moment. We've successfully solved this first problem, but I'd now like to show you a slightly different way. So at times we're going to need to use this other approach. Okay, so there's a special normal random variable which we're going to call a z variable, which is also called the standard normal distribution. So whenever you hear the term standard normal distribution, think z. So we're going to reserve the random variable z for a standard normal curve. Now what's special about this? Well, a standard normal random variable has a mean of 0 and a variance of 1. So the benefit of having this standard normal curve is that this standard normal curve has a measuring unit, which is the standard deviation. So every unit step corresponds to a standard deviation, or the variance of the thing. The variance and the standard deviation are both 1 in this case. Now, any normal random variable x can be converted into a z with this important formula. So this is extremely important. You're going to continue to see this all through the rest of this course and next course. If you take x minus the mean and divide by the standard deviation, you have converted that into a z distribution. Now, this standard normal distribution is so important that it has its own function in Excel, normSdist, for a standard normal curve. So let's go back to the sketch pad for a second, and I'm going to rework this problem by first converting it into a z. So let me show you how that is done. We can say that the probability of observing an x less than 175 is exactly the same thing as the chance that I have one of these z variables less than. Now we have to convert 175 into a z-score. So let's do that. So that's going to be 175 minus the mean. So remember, it's x minus the mean. Divide by the standard deviation. The standard deviation is 40. Now if you do the math, this is minus 0.25. This is a very important interpretation. So this minus 0.25 is telling us we are 1/4 of a standard deviation to the left of the mean. So we're 1/4 of a standard deviation to the left of a mean. Okay, so let's just think about this. One standard deviation is 40, so 1/4 of 40 is 10. So you'll notice that the distance between 175 and 185 is 10, so we're 1/4 standard deviation to the left of the mean. Now if I go back to Excel for a second, and this time I'm going to say normSdist, and let's put in minus 0.25, you're going to see that we get exactly the same answer. Okay, so this gives us exactly the same answer, 0.4013. So you can use either approach, either normdist or normSdist, but it is important for you to understand what the standard normal distribution is, that it has a standard deviation that is the unit of measure, and that's what these z-scores tell you, is how many standard deviations away from the mean you are. Okay, so that's the basic stuff that you need to know for the normal distribution.